In this video, we will learn one of the most important inequality in mathematics, that is Cauchy-Schwarz inequality. Cauchy was a French mathematician and Schwarz was a German mathematician. Okay. Sometimes it also called Cauchy-Schwarz Bunyakov's theorem. Bunyakovs was Russian mathematician. Okay. So, if V is an inner product space, so the statement of this inequality is let V be an inner product space if we consider two vectors V and W, if V W element of V, then the inner product of these two vector V W and then take their absolute value, because inner product can be positive or negative. So, if we take absolute value, then it would be always positive. So, this one should be less than or equals to norm of V times norm of the vector W. Okay. So, absolute value of inner product of two vectors is less than product of their individual norms. Now, we will prove this inequality. We will consider two different cases. In first case, we will consider both vectors V and W are 0, and in second case, we will consider both V and W are non-zero vector. So, proof. Case 1. In case 1, we consider V is 0, V is 0 vector or W is 0 vector. Okay. We consider either V is a 0 vector or W is a 0 vector. So, if V is 0 vector or W is a 0 vector, then the inner product VW is always 0, because if you take inner product with a 0 vector, then it is always 0. Okay. Now, and if V is a 0 vector, then what would be its norm? Its norm would be 0, because the norm of a 0 vector is 0. So, then VW, if you take the absolute sign, it does not matter because it is 0, equals to 0 equals to norm of V times norm of W, because either V is 0 or W is 0. So, if V is 0, then norm of V would be 0, and if W is not 0, then 0 times some non-zero number is also 0. Okay. Now, we will consider case 2. We can write here or we can write here actually. So, case 2, V is non-zero vector and W is also non-zero vector. So, in this case, both V and W are non-zero vector. Now, if V is a non-zero vector, suppose this is V, this is V, vector V, and W is also non-zero vector. Suppose this is W, suppose this is W. Now, if A is any real number, suppose A is any real number, then if we multiply this W by A, Suppose this is AW, where here A is more than 0. Okay, A is more than 0. If A is more than 1, then it will be bigger. It will be bigger. If A is less than 1, then it will be small. It is squeezed. Okay. So for any number A, element of F, we have 0 less than norm of V minus AW. So if this is V and this is AW, so what would be their difference? The norm of their difference, that should be either 0 or more than 0. If this one and this one length is equal, then it would be 0, and if not equal, then it would be more than 0. Now square it, square. So we know that norm of V square equals to inner product of V. Okay, we know that one, the relation between norm and inner product. So from this relation we can write this one as inner product of V minus AW comma V minus AW. Okay, so from this line we have 0 less or equals to V minus AW comma V minus AW. Now multiply. So if we multiply these two, so this is inner product of V. Now multiply these two. So here there is a minus, inner product of VAW, then multiply these two, so minus inner product of AW comma V. Now multiply these two, so minus minus plus AW comma AW. So here inner product of V minus, from the definition of inner product we know that if there is a here, then if we take A outside of inner product, then it becomes A conjugate VW. So A conjugate, because A can be real number or complex number, minus this one, if A comes outside, then it is just A WV, and here if this A comes outside, then it just A, and if this A come outside, then it's A conjugate WW. Okay. Now what we will do, suppose this is equation number 1. Now we will find the value of A conjugate. We will find the value of A conjugate. So to do that, we will set this part equals to 0. We will set this part equals to 0. So let minus A inner product of WV plus A prime inner product of WW equals to 0. We just set this one equals to 0. So if we divide the whole equation by A, then we have minus WV plus A conjugate WW equals to 0. So what is the value of A conjugate? So A conjugate is inner product of WV divided by WW. Okay. So this is the value of A conjugate. Now plug this value in equation 1. So plug the value of A conjugate in equation 1, then so if we plug the value of A conjugate here, so 0 more than or equals to, less than or equals to V inner product of VV minus A conjugate. Okay, so what is the value of A conjugate? It's this one, WV over inner product of WW times this one, inner product of VW. We do not need to write this part because we said this one equals to 0, this part equals to 0. Now simplify. So if we multiply both sides by inner product of WW, then it becomes inner product of VV times inner product of WW minus inner product of WV times inner product of VW. So this one we can rewrite as inner product of VW times inner product of, for this one WV, if we switch, then it would be VW conjugate. This is from the definition of inner product. Okay, this is less than or equals to inner product of VV times inner product of WW. Now this one, for any complex number, if Z is a complex number and Z is conjugate of Z, then it is absolute value of G square. Okay, so from that property we can write this one, absolute value of VW square less than inner product of VV. Inner product of VB is norm of V square. Okay, so this one we can write norm of V square, and this one we can write norm of W square. Okay, now if we take square root on both sides, then we will get our desired result. We will get this one. That means absolute value of inner product of VW less or equals to norm of V times norm of W. We are done. Thanks for watching.